Hello, so today we're going to be talking about the area of regular polygons. Now let's just recall that a regular polygon is a polygon with all equal sides and all equal angles. All equal sides and all equal angles. I'm using the symbols there. Okay, so the ones that we know, the most basic regular polygons we know are an equilateral triangle. That has all equal sides and all of its angles are 60 degrees. Okay, so an equilateral triangle. Another regular polygon that we know that has a really special name is a square. Has all equal sides and all of its angles are 90 degrees. All right, well, in order to get started with area of regular polygons, we do need to have some vocab to help us, okay? So we need to know what a central angle is, okay? A central angle is an angle whose vertex is the center of the figure. Okay, whose vertex is the center and sides contain consecutive angles. Well, that's kind of funky. So I'm going to draw one for you. So here, if I draw in a dot, that's my center, okay? And if I draw in a line to a vertex, okay, and then to another vertex, they create an angle. Remember, those are rays. So this right here is called a central angle. Now, if you think about it, if I drew in all of them, okay? If I drew in all of them and I connected them all the way around, then you might see that they form a circle, and that will be true every single time. So to find a central angle, all you have to do is do 360 divided by the number of sides, and that will give you each of those angles. So in this case, I would do 360, 1, 2, 3, 4, divided by 5. Okay. Another piece of vocabulary that we're going to know, and let me erase that for now so that you've got it drawn in, is the opossum. Opossum, whichever you feel comfortable saying. Teachers say it differently. It's the distance from the center to the midpoint of the side. To the midpoint of a side. All right, so here's the center. If I go straight down, it's a perpendicular segment, so it's perpendicular, and it hits the midpoint. That's the opossum, so we'll call it A, and that's the variable we're going to use for it. And we're going to need that opossum, and that perpendicular is going to matter. All right, a radius. A radius is the distance from the center to a vertex. So I'm going to change colors here. And so if I draw in a radius goes to a vertex. Kind of like the radius of a circle, except circles don't have vertexes, right? But it's the same word, so we're going to call that R, okay? And actually, let me move that A so it looks a little bit more on the side so we don't get confused. All right, so there's A, okay? All right, the perimeter, you know, perimeter is the distance around a figure. Okay, and then the area of a regular polygon. It is a new formula that I'm introducing to you, okay? So let me switch to green. How about that? The area of a regular polygon, you take 1/2 the apothem or the opossum times the perimeter. So we need the perimeter of the figure and we need that opossum. Now you may notice that the opossum and the radius, they form a right triangle. So we might be able to use that guy Pythagoras to help us, okay? All right, well, let's make sure we can understand this information. Let's look at this next figure. It says label the following for each. All right, so the opossum, I'm going to go to the center of the figure. Now be careful because we tend to want to draw an altitude. That's not what an apothem is or opossum is. It is a segment from the center to the midpoint of the opposite side. So if the apothem is like that, we would draw it in and we can label that 6. All right, a side. S is side, okay? So the side of the figure would be 12 root 3. The whole thing would be 12 root 3. All right, and then the radius would go from that center like that, and that would be 12. Now, you may notice that if the apothem or the apothem goes to the opposite side at its midpoint, then it makes this part right here 6 root 3. And that might look familiar to you. That's a 30, 60, 90 triangle because this is 6, the hypotenuse is 12, and the opposite side is 6 root 3. And that's because in an equilateral triangle, remember, they all have 60-degree angles. So that radius, when I drew it in, bisected the angle and made it a 30, 60, 90 triangle. Okay? All right, let's look at a square. Apothem, draw in your center. Perpendicular segment to the opposite side, so that would be 4. The side itself would be 8. And and this should say radius, so let's change that. The radius would be 4 root 2. Now again, that should look interesting to you because if the sides are all 8 and the apothem bisects or hits at the midpoint, then that would be 4 as well. Look at that, creating a 45, 45 or an isosceles right triangle. All right, let's look at this one. 6 sides, it's a hexagon. I draw in my center, my apothem, straight down. It's 4 root 3. My side length, 8. I can put that anywhere because they're all equal, right? I could put it all the way around if I wanted to. And then my radius of 8 as well. All right, and you may notice that because the apothem cuts it at the midpoint, then this becomes 4. And that might even look interesting to you because that's another 30, 60, 90 triangle being created. All right, so let's find some more information. It says, find the following information. It gave us a regular polygon. I'm telling you these are all regular, so let's write that. Regular polygons. And it wants us to find the central angle and the apothem. Okay, so the first thing that I tend to do for the central angle is just do 360 divided by, there's 3 sides, okay? So that gives me an angle of 120 degrees. That's important, okay? 120 should make you think 60. Because the central angle is this. This is 120 degrees, right? So I'm going to actually put that in blue. I don't want to draw it in because it's going to get messy. So when I draw in my apothem, and I'll do that, I'll change that to green, like that, and my radius is 20, I've actually created a 30, 60, 90 triangle. So first of all, my central angle is 120 degrees. Now I've got to find my apothem. So I'm going to actually redraw this little triangle for myself with a 60, a 30, and a 90. And I have a hypotenuse of 20. So just to recall, in a 30, 60, 90 triangle, the short leg is half the hypotenuse. So it's x, 2x, and x root 3. All right, so across from 30 would give me 10. So then I know my apothem is 10. And just because we might need it at some point, this segment right here would be 10 root 3. So that's 10 root 3. All right, let's try it again. In the next one, I'm going to give you some information. The radius is 8 root 2. All right, so first we want to find our central angle. Remember, our central angle is the angle created with the 2 radiuses. So I do 360 divided by 4, which gives me 90 degrees. Okay, I have to find my apothem, so I draw in my side right there. I know if the whole central angle is 90, then I know that each little part is 45, and it is a square. This will always be true. It creates a 45, 45, 90 triangle, and you may recall that if in a 45, 45, 90 triangle, if I have the hypotenuse of 8 root 2, I divide by root 2 to get the side length back, so each side would be 8 and 8. So that's 8 and that's 8. All right, one more. We've got a hexagon, 6-sided figure, okay? So to find the central angle, remember the central angle is formed by the two radiuses. I just do 360 divided by the number of sides, which is 6. That's going to give me a 60-degree angle. I like that. Okay, that 60-degree angle right there, when I draw in the apothem, it bisects the angle, creating a 30, 60, 90 triangle. So be very careful though. Notice the 30 is in a different location compared to that equilateral triangle. Okay? All right, we have a hypotenuse of 6. Now remember, it's always the short leg that is half the hypotenuse. Always the short leg, and the short leg is across from 30. So that would make this segment 3, and then 3 root 3 across from the 60. So 3 and then 3 root 3. So my apothem is 3 root 3, and my central angle is 60 degrees. All right, now let's put that all together to see if we can find the area of a figure. So on the next page, it says, okay, so it gave you a square, and I'm going to draw in a radius of 20. So similar to what we just did. We had already calculated that the central angle was 90 degrees. We did 360 divided by n, so 360 divided by 4. It has 4 sides, and we need to find the side length. Okay, so the first thing that I'm going to do is I'm going to draw in another radius, because that's what I like to do. And I'm going to drop that altitude, that apothem, and I know that I'm breaking this into two 45, 45, 90 triangles. I take 20 to find the apothem. I take 20 and I divide it by root 2 to work backwards. Remember, in a 45, 45, 90 triangle, it's x, x, and x root 2. All right, so I divide by root 2. I have to rationalize my denominator. So multiply by root 2 over root 2. That will give me 20 root 2 over 2. And then I do need to simplify that. 20 and that 2, those are rational numbers. So since they're both rational, I can simplify. 2 goes into 20 10 times. Okay, so that gives me an apothem of 10 root 2, and this piece right here is 10 root 2. All right, so I've got an apothem of 10 root 2. Well, I need the side length of one of the figure. So if each piece is 10 root 2, that means that the whole length is 20 root 2. Remember, adding root 2 plus root 2 is like combining like terms, okay? So be really careful that you don't try and change that radical. All right, so I have a perimeter then. I have 4 20 root 2s. So I multiply that by 4. Remember, I can only multiply the rational rational parts. So 4 and 20. So my perimeter would be 80 root 2. All right, so now the area formula we talked about earlier. Area of a regular polygon is equal to 1/2 apothem times perimeter. So I have all that information, which actually is the same thing as apothem times perimeter divided by 2. So let's plug in what we have. We have 80 root 2 times 10 root 2, all divided by 2 to get the area. All right, now I like to simplify before I multiply to make it a simpler question. So I'm going to divide 2 into the 80, and that's going to give me 40. Once I've done that, that 2's gone. All right, so now I have 40 times 10, which is 400. Remember, multiply the first numbers. You have 2 zeros, so keep the 2 zeros. Then I have root 2 times root 2, which we've talked about a lot recently, is 2. So 400 times 2, that gives me an area of 800 units squared. Okay? All right. Here we go. We're looking at an equilateral triangle, and I'm going to give you that the apothem in this triangle. Oops, I'm sorry. I'm going to have you try. So I'm on a square. So I'm going to give you that the apothem of the square is 8. okay? I'd like you to find all of the missing pieces and then calculate the area. So press pause and come back. Okay, so if you did that, you would have had number of sides 4, central angle of 90. You would have gotten a side length of 16, a radius of 8 root 2, a perimeter of 64, an apothem of 8, and the area would have been 1/2 8 times 64. I would have simplified 2 into 64 32 times, and then 32 times 8 is 256 units squared. Okay, so let's try it on an equilateral triangle. I'm giving you an equilateral triangle, and I'm going to tell you that the apothem is 8. All right, so we already know that it's a 3-sided figure and that my central angle is 120 degrees from that previous problem. I'm going to draw in my radius. Actually, I like to draw in 2 radiuses just to help me. If it's 120 degrees central angle, I've created a 30, 60, 90 triangle with this angle being the 60. Okay, so I have the side opposite 30. So I have the short leg, so that tells me my hypotenuse is 16, and that my long leg, so across from 60, is 8 root 3. So my radius is 16. I double 8 root 3 to get the side length of the figure, which is going to give me 16 root 3. And then to find the perimeter, I multiply that by 3, because there's 3 sides, which is going to give me 48 root 3. All right, so my perimeter is 48 root 3. The apothem was given to me of 8, and now I plug those right into the area formula. Area of a regular polygon is apothem times perimeter divided by 2, or 1/2 AP. All right, so my apothem is 8. My perimeter is 48 root 3, and I divide that by 2. All right, I like to simplify before I multiply. So I'm going to simplify the biggest numbers. So 2 goes into 48 24 times. Then I multiply the rational parts here. So 8 times 24, which is going to give me 192 root 3 units squared. And that's an exact value. Okay, I want you to try one, and then we will review tomorrow in class. So I'm going to give you an equilateral triangle, and go ahead and draw in a radius of 20. I'd like you to calculate all of the information asked for as well as the area. We'll check tomorrow and we'll do some more practice. Have a great night.